Okay, here's our lesson, 4.2, arithmetic sequences. So yesterday we learned that sequences were a set of numbers in a pattern, and it could have been any pattern. So for example, we could talk about our even numbers, right? 2, 4, 6, 8. Or we could talk about maybe doubling. So we could do 2, 4, and then double 4, we get 8. Double 8, we get 16. So these are all sequences because there is a pattern, and you could figure out what the next number is. An arithmetic sequence is something very special, and we can see it in the patterns below. So in these two examples at the bottom, they've given us some patterns to consider, and what we want to do is figure out how are they getting the next numbers? What is the pattern? So if I look here, we try to think about what's happening every time. On all of these, they're adding 2, right? Plus 2, plus 2. So we could actually figure out what the next term was. On the other one, you may notice here we're going down. So I'm going to pause for a second, give you a second to think, what's the pattern? And you should notice that we're subtracting 4 every single time. These are both examples of arithmetic sequences. So the definition of an arithmetic sequence that you want to write down is that it's a sequence where you add or subtract the same amount each time. And there are some special parts. So just so that we kind of review some notation, remember our first term is always called f of 1. So like in this example, we'd have f of 1 equals 3. If we tried that one, it would be f of 1 equals 33. Those are our first terms. And then this change that's happening every time, they call that the common difference. And it's called common because it's the same every time within a single problem. Obviously, you see that they change from problem to problem. All right, those are called these two patterns are called the common difference. Here, I'll draw that in green. Common difference right here and right here. Those are the common differences. So that's what makes something arithmetic. So let's look at some examples. This just says determine if they're arithmetic or no. So in my first one, I just kind of want to map out. I'll zoom in here. You just need to watch this and maybe write 1 or 2 of these down. So I'm just going to map what's my pattern. Is it arithmetic? So this is plus 4, plus 4, plus 4. That's the same every time, so I'm going to say yes, that is arithmetic. And the common difference, which they're actually going to call D, is 4 because it's going up 4 every time. On this next one, I've got plus 3, plus 3. You can think of a number line if you need to. From -4 to 1, though, is plus 5. So because that's not the same change every single time, this one is not arithmetic. Not arithmetic. All right, hopefully that makes sense to you. We're not going to worry actually about the fractions and decimals, so you may want to get those down. And then at the bottom, it's asking us for the yes above, find the next 3 terms. So if we were to continue number 8, they have already given us these first terms. And to find the next 3, you probably don't even need me to say it, but all we're going to do is continue the pattern. So to keep going, I would need to add 4, which is going to give me 13. All right, pause the video for a second, see if you can fill out the other 2. All right, now that you've had a second to try, let's see if you have the right answers. So 13, 17, 21. If you didn't get that right, go back and rewatch or take a second to think about maybe how I got those answers. The big part of today is where we're going to try to write formulas, and there's actually a third way to write them, but we're not going to worry about that until next chapter. So recursive, let's remind ourselves, recursive is when we have to use or know the previous term. And from yesterday, we learned that the previous term was called f of n minus 1. So there's two parts to a recursive formula. The first thing I need to do is state what my first term is. All right, so I'm going to say my first term, I'm going to call it f of 1, equals 8. Right, I'm just looking up here at the top and determining that my first term is 8. The second step that we need to do is determine what is my common difference. So my common difference here, I'm going to look at the pattern above, and I want you to pause the video and take a second to think, what's the pattern? And the common difference is going to be, if you looked at the pattern, I'm going to get d equals 3 because they're adding 3 each time. That's what that means. We're going to add 3 each time. So recursive, remember, we just tell ourselves how to get to the next term. So again, there's two parts to a recursive formula. So I'm going to write formula down here so you know I'm actually writing the final answer. Formula. So my formula, I need to say two things. First, I need to tell us where to start. F of 1 equals 8. And f of n, so that's any other term, is the previous term, which we write f of n minus 1. If you want to label your notes, you may want to remind yourself that this is the previous term. So that's the previous term, and then we're adding 3, so plus 3. Super easy. You just have to say what the first term is, and then just pay attention to the notation here so you know how to write for the rest of it. You're going to add 3. Now I told you there's some different ways to write it, and here we're going to write the explicit formula. If you have not made sense of what's happening so far, you need to pause and go back and re-watch the first part of the video. This slide is going to take me a minute, so you may want to re-copy down our pattern up here and then write explicit formula so you can make sense of kind of how we're going to write this. And I'm actually going to change some things about what is written so far. So the first term, if you want to like make a little table in your notes, the first term, we don't ever actually write this notation because we're better than that, right? Our notation for first term is going to be f of 1. And that means, so in terms of the first term, that's just the first term itself. So f of 1, that seems silly to even write, but f of 1 equals f of 1, which is 8. We talk about our second term. We would call that f of 2, and think about how do we find that second term? Well, we take the first term, which is 8, and we have to add 3 to it, which is d. So I can write 3 here, or I'm actually, instead, I think I'm going to write d, because that's my difference every time. So that is 8 plus 3 equals 11. All right, that should kind of make sense so far. This is where it's going to get a little tricky. My third term, where I write f of 3, and think about the question I'm asking is how can I get 14 from 8? So if I was to skip the 11, how could I get there? Well, that means I need to do the first term. And because I'm going to skip one, I actually have to add this d value twice. So that's like saying 8 plus 3 plus 3. I'm going to write one more line just so we kind of have a pattern to follow so we can figure out what's going to happen in general. So the fourth term, f of 4 equals the first term, which is 8, plus, if I want to get to 17, I've got to add 3, add 3, add 3. All right, look up here at the top and rewatch that part. Add 3, add 3, add 3. That means I added 3 of the d's. That gave me 17. So pay attention, and I'm going to adjust. Instead of putting plus 2d in red right here in the middle, I'm going to change that. I want to say 2d. I want you to notice a pattern. When I found the second term, I added d one time. When I found the third term, I added d twice. When I found the fourth term, I added D 3 times. Right here, I'm going to draw, I just want you to really connect. Every time you're adding one less D than the number term you're finding. Re-listen to me say that. Every time you're adding one less D value than the number you're finding. So for example, if I skip to like the 17th term, it would be f of 17 equals the first term plus 16D. It was 16 because that's one less than 17. So my general form, I know that is kind of tricky to think about. The big part that you really need to have in your notes to find the explicit formula. So I'm going to zoom out for a second so we can really see. To find the explicit formula here, it's f of n equals the first term, f of 1, plus, instead of n terms, I want it to be less than that. So I'm going to say n minus 1 times d. Now that may not make a ton of sense to you in that notation, but if you followed what I did in the table, you just need to remember this formula that I'm giving you. So let's think about how would we do that with this specific problem. All right, I'm going to do one example in two different ways just so that you can compare the two. Recursive is when you use the previous in your equation. So what I would write here, if they were asking me to write a recursive formula, I would have to first say that the f of 1 is 10, and I need to say f of n equals the previous term plus, and this is actually not plus, this one's minus. Think about what's happening every time. Minus 2. There is my recursive formula. Make sure you understand where that's coming from. All right, my explicit is just a little trickier. So my explicit, I don't have to say what the first one is, but the general form is f of n equals the first term plus n minus 1 times the difference. So f of n. Now I want to ask myself, what is the first term? And here, the first term is going to be 10. I'm just getting that from above. Plus n minus 1. I don't know what n is, so I keep it in there. The other part I have to fill in is d, and the d is my difference. So this is going to be times, how is it changing? Negative 2. This is the formula you're going to write for that. If they were to ask you to find, last part of our example, let's say they're going to ask us to find the, let's say the 17th term. The recursive formula is easy to write, but it would be very difficult to use this side because you'd have to count all the way up. So we don't want to do that. That word is difficult. Okay, we want to use this side over here. So don't do this way. We want to use the explicit formula. And the way you would do that, you would say f of 17 equals 10 plus, and you can either plug this in or remember the pattern. And now you're just going to work that out. I'll work it out in yellow. So 10 plus 17 minus 1 is 16 times negative 2. I have to do my multiplication first, so that's 10 minus 32 equals negative 22. So that means the 17th term is negative 22. All right, that's all we've got for today. We'll work on these problems in class tomorrow.